Okay, let's quickly whip through exam 1 and see where you might have gone wrong. So question 1 is a straight up just testing skills. So f of 3 equals negative 3 squared plus 4 times 3 plus 5, which is negative 9 plus 12 plus 5, which is 8. F dash x is equal to negative 2x plus 4. F dash 3 on 2 is equal to negative 2 times 3 on 2 plus 4. That's going to be negative 6 on 2, which is negative 3. Negative 3 plus 4 is 1. F dash x equals 7, so 7 equals negative 2x plus 4. 3 equals negative 2x, x equals, what is that, negative 3 on 2. All right, show that the equation of the normal at 3, 8 to that is that. So remember, basically what we just can't use that, okay? So what we need to do is, we know that the point is 3, 8, so we've been given that. We need to find or use f dash x, which is negative 2x plus 4. And what we're going to do is find the gradient of the tangent at x equals 3. So f dash 3 is equal to negative 6 plus 4 equals negative 2. So m tangent is equal to negative 2. That means m normal is equal to the negative reciprocal of this, which is going to be a half. All right, so I usually slap this into y take y1 equals m x take x1. That is going to be y take 8 is equal to a half x take, or what is it, take 8, is it? No, I think I got them the wrong way around. X take 3. All right, y take 8 equals x on 2 take away, what is it, 3 on 2. Y equals x on 2 take 3 on 2 plus 8 on 16 on 2, which is y equals x on 2 plus 13 on 2 as required. Okay, intersects with f of x at one other point. Find the x value of the coordinate of the other point of intersection between, okay, so that's going to be us equating the equation of the normal with f of x, which was negative x squared plus 4x plus 5, negative x squared plus 4x plus 5. Okay, probably the easiest way to do this is to get rid of those 2's by multiplying everything by 2. So we've got x plus 13 equals negative 2x squared plus 8x plus 10. Then let the left equal 0, negative 2x squared plus 7x take 3. Dump the negative by dividing both sides by negative 1. Check you can go through via the cross. 3, 1, 2x, x. What do we need? Negative 7. And they can both be negative, yeah. Negative 6x, negative x. Yeah, there we go. So 2x take 1, x take 3. So we knew that we had one intersection at the point where the normal exists, and there's the other one. So we'll go x equals 3, x equals a half, but other x coord required only. So x equals a half. So this one here, we already know that it is that point there at x equals 3, and we require an answer of the other point. So there's the other point. Right, so some skills-based questions here. Evaluate the following. So 3 raised to what power gives me 9? The answer is 2. 3 raised to what power gives me 27? The answer is 3. 3 raised to what power gives me 81? The answer is 4. 2 plus 12, 14. What's your order of ops there? This one here is 4 raised to what power gives me 16. So that is 4 to the 2. This one here, we're going to write it as log 3 to the half, which is 2 plus half log 3, 3. Log 3 is just 1, so it's 2 plus a half, which is 5 on 2. Evaluate this. So the sine of 5 pi on 3, so that's that. So that is going to be the same as sine of 6. No, we're in the wrong spot. That is down here. Okay, so that is going to be root 3 on 2, negative root 3 on 2 times 3, which is negative 3 root 3 on 2. Right, and this last one, n is an element of z, so z that's like 0 or negative 1, 0, 1, 2, 3, that's all integers. So n can be any of those numbers. So basically what that's going to do is, like think about it, if n is 1, that's going to be 2 pi. If n is 2, that's going to be 4 pi, 6 pi. It's basically going to be even pi all the time. So we're going to end up here in every instance. So the answer to this one is just 1. Okay, Mr. Tench goes for a run in a straight line and notes that his displacement x meters from the origin at time t seconds is given by this function. What is his average velocity between t equals 0 and t equals 3? So average vel equals x of 3 take away x of 0 all over 3 take away 0, which is 3. Now, let's do x of 3. That's going to be negative 9 plus 9 plus 10, so that's 10. Take away 0 is going to be 10 over 3. So that's 0 over 3 equals 0 meters per second. When will Tench reach the origin? What is his velocity at that time? So what we'll do is, to get when he reaches the origin, we're going to find out when his position is at the origin. So I'm going to say 0 equals negative t squared plus 3t plus 10. So what I want to do is solve that. So I'm going to divide both sides by negative 1. So t plus 2, t equals 5, t equals negative 2, but t greater than 0 or greater than or equal to, therefore t equals 5. So now what we'll do is use that answer there. I'm going to get my velocity function. So x dash t is the velocity function, negative 2t plus 3. And what I'm going to do is find out its instantaneous velocity at that time. So x dash 5 is equal to negative 10 plus 3, which is negative 7. Okay, so we've got a log sketch here where it's between 0 and 8. All right, so this negative 1 is a vertical translation. So what will happen is it'll still be asymptotic down this line here. So the asymptote doesn't move. And it's going to go something like that. Let's solve it. So 0 equals log 2x, take 1, 1 equals log 2x, 2 to the 1 is 2 equals x. So there's our x-intercept there, and we want it to terminate at 8. So log 2, 8, take 1, 2 raised to what power gives me an answer of 8. That's going to be 3. 3 take 1 is 2. So this is where it terminates and it's included. All right, so let's see if we can graph this. There we go. That's everything. Okay, the graph of that undergoes those transformations. Okay, so probably best go with the mapping or function if you know it. Dilation by factor of 2 from the y changes x at 2x comma y. 1 unit to the left, 2x take 1, y reflection in the x changes y. Okay, so what we'll do is we'll solve for x and y. So I've got x dash plus 1 on 2 equals x and y equals negative y dash. Right, so my function is negative y dash equals log 2 x dash plus 1 on 2, take 1. Right, let's just clean that up a bit. Y equals negative log 2 x plus 1 on 2 plus 1. So I'm dividing this whole right-hand side by negative 1. Right, state the domain of the new function. So the original domain was 0, 8. When we dilate from the y-axis, it's going to become 0, 16. So to basically like stretch it out. Translation 1 to the left. Negative 1, whoopsie. Negative 1, 15. And what was the last one? Reflection in the x-axis. So the reflection in the x-axis won't change the domain. So basically, if you want to think about it, what happens is this graph here, it gets dilated. So like it'll go to 16. Then it shifts 1 to the left. So that point there and that point there, and the asymptote will shift over. And then it reflects in the x-axis. So it'll be like become like that. Still have the same domain, but it won't. Yeah, so the graph will look different, but it'll still have exactly the same domain. So our answer there is negative 1, 15. Okay, solve for x. 2 to the 3x plus 3. Okay, so negative x equals 3. Is that right? X equals negative 3. Okay, the log solve. So what you can do for this one here is you can equate the logs because they're the same. We're going to say x squared take 5 equals this is the same as that. X squared, what are we doing? Take x, take 6 equals 0. that's the negative. X take 3, x plus 2 equals 0, x equals 3, x equals negative 2. Make sure you test your answers, and there will be a problem with this one. Okay, so this is the problem here, x equals negative 2, because 1 plus negative 2 is negative 1. So that, yeah, that's going to be a problem there. 3 is okay. 3 squared is 9. 9 take 5 is 4, so that's okay. So we're going to say reject x equals negative 2 as out of domain. So, or we won't say out of domain, we'll say as log 2 negative 1 not defined. So x equals 3. Okay, this one here, what we'll do is we'll write this as quarter to the x less than. This is going to be 64 is 4 to the 3. So this is going to be 4 to the 3 to the 1/3, which is a quarter less than. So that's going to be a quarter to the 1. Okay, now just to sort of make sure that we can treat this inequality sign correctly, we'll write this as 4 to the negative 1 to the x less than 4 to the negative 1 to the 1. Power to power rule, 4 to the negative x less than 4 to the negative 1, negative x less than negative 1, x greater than 1. All right, 3 marker trig solve. Cosine 2x equals negative 4 on 3 over 8. Cosine 2x equals negative root 3 on 2. All right, so what's our base angle? It's going to be pi on 6. All right, and when is cosine going to be negative? So it's going to be there and there. So 2x equals 5 pi on 6, 7 pi on 6. Then we've got to add another 2 pi, which is 12 pi on 6. So it's going to be, because like I know that this here will dilate for me, so we need to include another full set of solutions. So that's going to be, what is it, 17 pi on 6, 19 pi on 6, then divide those solutions by 2, 5 pi on 12, 7 pi on 12, 17 pi on 12, 19 pi on 12. All right, so this graphing question, what we've got here is a cosine graph inverted and up 1 unit. So essentially the standard cosine graph will look like that. It's gone up 1 unit and it's inverted. So it's going to come up like so. So we're going to get some action happening on the left side because that's our domain. All right, so let's get stuck into it. Our period is going to be 2 pi over half, which is 4 pi. Scale is going to be pi. So every pi we get some action, I suppose, if you want to think about it. So it would be typically, we would start there and go down, but because of the translation up, we start there and then we've got that reflection, so we're going to start here, goes to there. That means that before there, it's going to be, What is it? There, I think, yeah. Okay, so that's probably the worst ever trig graph, but yeah, you guys needed to do a little better than that, given that you didn't have to draw it on a screen. So that's the endpoint, turning point, and endpoint. Okay, horizontal line has the function g of x equals c. State the values of c for which there is a maximum of one intersection. So basically, what you want to imagine, horizontal line drawn through the graph, got one intersection there. Along here, we're going to get those two intersections, which is the endpoint plus this point here. We're going to get one intersection there. Over here, we're going to have 0 intersections. So the answer to this is going to be where state the values of c. So c is an element between. So this is going to be 1. So we're not allowing 1 directly. All the way up to 2, you are allowed to choose 2. This question had one more twist though in it, in that you could also get one intersection along this line here, which was the turning point, and then 0 intersections. So the notation, we were pretty lenient on it. You could have just gone union with 0 if you wanted, or any other ways to state that. We didn't really care. If you could pick the right ones, then we were happy for you to mix set and interval notation. Okay, and on to the final question. So x cubed take away ax squared, where a is a positive number, is pictured. Find f dash x, okay, and hence find the coordinates of the stationary points. Okay, so, oops, wrong exam. Okay, so f dash x equals 3x squared take away 2ax. State the coordinates of the stationary points. So let's find out where the x values of the stationary points are by setting the derivative to 0. 0 equals x. 3x take 2a. Naturally, one of them is x equals 0. The other one is x equals 3x take 2a equals 0. 2a on 3. So there's our first coordinate. So there's one of the stationary points, 0, 0. The other one is along here at the x value 2a on 3. So to find out the y value, we're going to do f of 2a on 3. So we need to pop that into the original function. So that's going to be 2a on 3 all cubed, take away a lots of 2a on 3 squared. Okay, 8a cubed over 27 take away 4a squared on 9 multiplied by a is 4a cubed on 9. Now times 3 times 3 equals 8a cubed take away 12a cubed all over 27. It's negative 4a cubed all over 27. Yeah, sounds about right. Okay, over what domain is it strictly decreasing? So it's between there and there. Okay, So for strictly decreasing, what we do is we can include the endpoints because it'll still be strictly decreasing if you choose one of the endpoints. So it's going to be between 0 and 2a on 3. Sketch the graph of f dash x on the same axis above. Okay, so we've got a 0 gradient point here, a 0 gradient point here. Now we've got a negative gradient between here and here, so we just need to draw something negative, and a positive gradient and a positive gradient. Cubic goes to a parabola, so we've got an upright parabola as f dash x, where this one is f of x. Okay, done. A point a, q, f of q lies on the graph of f. The tangent is drawn to the graph of f at the point A. So somewhere along the graph is a point A and a tangent is drawn. No other tangent to the graph of f has the same gradient as this tangent. Find q in terms of A. All right, so basically what that's saying is we're choosing a point along this, which is A, f of A. Or I think it was a Q. Yeah, Q, sorry. So Q comma f of Q. Right? And what we want to do is note that that can be drawn anywhere along here, but the condition of the question is such that this has a unique tangent. Okay, so it can't be at this point here, because if I draw a tangent there, that along this side there'll be a tangent that has exactly the same gradient. Right? Now, the reason we got you to draw the f dash x function is that you'll notice that this is the gradient function, and this is basically saying that we can produce these two gradients here, these y values here, or these f dash x values, are produced when x is equal to this and x is equal to this. So what that means is that we can get two versions of this same gradient for different values of x. If we keep going down, the only time we're going to get one value is actually at the turning point. All right. Now, this is 0, 0, and this is 2a, comma, whatever, f of 2a on 3, whatever that was, I can't remember. And the turning point is going to happen, because it's a parabola, it happens halfway between 2a on 3 and 0, which is just going to be a on 3. So the answer to this question is Q, this point here, it's going to happen if you draw the tangent at Q equals a on 3. All right, and that is at this point here. So the tangent is going to be completely unique. That's the only version of the tangent you're going to get. Now, the other thing you can do for this is some students who answered this one did the double derivative. So what they did was derive f dash x, which was 3x squared take 2ax. So it's going to be 6x take 2a. And they let that equal 0. So they basically found out when that would be 0, which is going to be 2a equals 6x, x equals 2a on 6 equals a on 3. Therefore, q equals a on 3. So that was two ways of doing it. This was the way we really had intended. We didn't really want you to hit the double derivative, but a couple of you guys knew that and did that, which was good. Not many students got this one, by the way. All right, so there are the exam 1 solutions.